Hello, this is Keith Capello from K-Dawg Weather. Today I'm going to be talking about turbulence. So if you could please like and subscribe to this channel. Thank you. Okay, today I am going to talk about aviation turbulence, understanding the science, safety, and future of flight through rough air. What is turbulence? Turbulence is irregular, chaotic air motion that produces rapid and unpredictable changes in aircraft's attitude, altitude, airspeed, and load factor. 30%, 36% of all Part 122 air carrier accidents in between 2008 and 2022 is the leading cause. 100 million plus a year is the cost to airlines from injuries, damage, and rerouting. Survivable. Modern aircraft are built to withstand forces 1.5 times beyond design limits. Here is the turbulence intensity scale. The intensity ranges from light, moderate, severe, and extreme. We'll start off with light. The EDR range, which is eddy dispatch rate, which means is the international standard for measuring turbulence. It describes the atmosphere itself, not just aircraft response. Greater than 0.15. The G-force is plus 0.1 G. Cabin experience, slight bumps, drinks stay put. Next intensity is moderate, 0.15 to 0.35. The G-force is 0.5 G. The cabin experience is definite movement, seatbelt sign on. Severe, 0.35 to 0.45 plus 1.0 G. Unsecured objects airborne. Extreme, greater than 0.45, greater than 1.5 G. Aircraft may lose control temporarily. Clean air turbulence, the invisible threat at cruise altitude. What is it? Turbulence in cloud-free air at high altitude, invisible to weather radar and the naked eye. Primary cause is wind shear near jet streams, abrupt changes in wind speed and direction between air layers. Where it occurs, between 50 to 150 miles on the cold side of a jet core near upper level troughs and fronts. Why is it dangerous? No visual warnings. Passengers and crews are often caught unbelted when it strikes suddenly. Convective turbulence is generated by vertical air currents from surface heating, the most common type of turbulence in fair weather. Thermal updrafts. Sun heats the surface unevenly, creating rising columns of warm air. Strong over dark surfaces like asphalt and plowed fields on hot afternoons. Thunderstorm cloud cells. Tense convective turbulence in and around cumulonimbus clouds. Updrafts can exceed 66,000 feet a minute, with severe downdrafts nearby. Microburst. Concentrated downdrafts that spread on contact with the ground, extremely dangerous during takeoff and landing phases. Mechanical and mountain wave turbulence. This is mechanical turbulence caused by surface friction and obstacles disrupting smooth airflow. Buildings, terrain, and vegetation create eddies near the surface. Most intense at low altitude and strong winds. Common near airports with nearby structures or terrain. Mountain wave forms when stable air flows over mountain ridges, creating oscillating waves that can extend to the stratosphere. Rotor zones beneath waves Stress causes severe turbulence. The lenticular clouds are visual indications of wave activity. Wake turbulence. Vortices generated by aircraft wingtips, a human-made hazard that demands careful separation. 2 to 4 nm, required separation behind heavy aircraft. 6 nm, which is nautical miles, required behind super heavy A380. 900 feet minimum vortex sinks rate initially. Wingtip vortices are strongest behind heavy, slow, clean configuration aircraft. Vortice sinks at 400 to 500 feet a minute and persists over several minutes. Crosswinds can drift vortice into adjacent runways or flight paths. ATC enforces mandatory spacing intervals based on aircraft weight categories. How pilots detect and avoid turbulence. Weather radar. Onboard radar detects precipitation and convective cells, but cannot see clear air turbulence. Pilots report provide real-time turbulence data from other aircraft along the route, which is PIREPs. EDR sensors, automated eddy dissipation rate systems on Delta, United, and Southwest generates 65,000 plus reports daily. Forecast tools. GTG, which is Geographical Turbulence Guidance, provides 2 to 12-hour turbulence forecasts using model data. Passenger safety. Most turbulence injuries happen to unbelted passengers and cabin crew, not from structural failure. Number 1. Keep yourself seat-belted fastened at all times when seated, even when the sign is off. Number 2. Stow heavy items in overhead bins securely and keep carry-ons under the seat. Number 3. Follow crew instructions immediately when the seatbelt sign illuminates. Number 4. Choose a seat over the wing for the smoothest ride closest to the center of lift. Number 5. Check turbulence forecasts before flying using apps like Turbulence or airline weather maps. Number 6. If standing, brace yourselves by gripping seat headrest. Avoid walking during advisories. So far, 207 reported injuries on U.S. commercial flights between 2009 and 2024. 5,000 severe turbulence events over the U.S. per year. 1.5 times the safety factor aircraft are built to withstand. Built to handle it. How aircraft engineering makes turbulence a non-issue for structural safety. Wing flex testing. Wings tested to flex up to 25 feet beyond normal range. Boeing 777 wings bend at 24 feet upward during certification without failure. Gust load criteria. Certified under the FAA EASA gust load requirement that simulate extreme vertical wing gusts at all flight speeds and altitudes. 1.5 safety margin. Every structural component certified to 150% of maximum expected stress. This covers the worst turbulence the atmosphere provides, with margin to spare. Continuous monitoring. Flight data recorder and structural health monitoring track cumulative stress. Aircraft are inspected after every severe encounter. Climate change and turbulence. 55% increase in severe clear air turbulence at some locations from 1979 to 2020, according to a 2023 University of Reading study. Jet stream intensification. Climate change, increased temperature gradients in the upper atmosphere, strengthening jet streams, and the wind shear that causes CAP. For every 10 minutes spent in severe turbulence today, it could be 20 to 30 minutes in the future. The atmosphere scientist Paul Williams. The economic impact. More turbulence mean more fuel burned on diversions, more inspection downtime, and rising costs that currently cost 1 million plus annually. 100 million plus annually, sorry. Here are some notable turbulence incidents. May 2024, Singapore Airlines SQ321, London to Singapore, 178-foot drop in 4 seconds over Miramar, 1 fatality, 104 hospitalized, severe clear air turbulence. July 2025, Delta Airlines, Salt Lake City to Amsterdam, severe turbulence at 37,000 feet, 2 serious injuries, 18 hospitalized. July 2024, Air Europa, 20 passengers injured during severe turbulence, led to Singapore declaring turbulence at a state-level safety risk. Note, Singapore has now classified severe turbulence at a state-level operation safety risk, alongside mid-air collisions and loss of control in flight. The future of forecasting. In situ EDR systems. Automated turbulence sensors on Delta, United, and Southwest generate 65,000 plus daily reports, spanning to more airline and cockpit laptops. AI-powered forecasting. Machine learning models trained on decades of atmospheric data are improving turbulence prediction, accuracy, and lead times. LiDAR detection. Forward-looking LiDAR can detect clear air turbulence 10 to 30 kilometers ahead, giving pilots 1 to 2 minutes of advance warning. Global harmonization. Internal collaboration to standardize EDR observation and forecasting, replace subjective plots, pilot reports with objective measurements. Here are the key takeaways. Turbulence is normal atmospheric phenomenon. Aircraft are engineered to handle it. Clear air turbulence is invisible and increased due to climate change. The seatbelt is your single most effective safety tool. Technology is rapidly improving detection and forecasting capabilities. Severe incidents are rare, but underscore the importance of staying belted. Remember, fly informed, stay buckled, trust the engineering. Okay, this is Keith Capillaro from K-Dawg. Thank you very much for watching this PowerPoint presentation. I hope you enjoyed it. If you could, please like and subscribe and give a thumbs up to this channel. And thank you, and fly safe, and have a wonderful day.